I don't see any blood. With the world of probability, ladies and gentlemen, we have what we call theoretical probability, and we have what's called experimental probability. And the one we're talking about today is this one. Did we talk about this? What's the difference between theoretical and experimental? And a lot of times you'll hear people say, well, theoretically speaking, blah, 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 blah. Keith?
Theoretical is just like thinking about it, like if you have there is what should happen, and then experimental is what actually does happen.
Yeah, this is, theoretical is what mathematically should happen. It's what should happen. Whereas experimental is what actually does happen. When you do, you have to physically do the experiment to get experimental probability. And there are some things that you can't figure out theoretically. It's all experimental, right? For example, if I went with, I can't use Jade because he doesn't miss. If I went with Elijah and saying what's the probability of Elijah making his next free throw, okay, there's no mathematical formula that would figure that out. But Elijah's probably shot some free throws in some games. And let's say he shot, I don't know, let's say he shot 10 free throws in games and he's made 5 of them. Well, the probability is that he, out of 10 times, he made 5 of them. So his experimental probability is that, you know, he is 1 for 2 or half. His probability is 1/2 that he's going to make that one. I'm going to go to the bathroom because I have a hard time concentrating. The whole thing. Can you just use one and keep using it or something? Experimental and theoretical. Same thing with batting averages for professional baseball players. You know, that is like probability. What's the probability that what's his name's going to get a hit? Well, you know, what's a good batting average? We say somebody's batting average is 300. Well, that is experimental probability, because what's that said is, you know, the guy's been up 300 times out of 1,000, and he gets a hit 300 out of 1,000 times. That is experimental. There's no theoretical probability there, because you can't mathematically figure out somebody's talent to be able to do some of those things. And that's the case here. Right out of the book it says this. It says a softball player hits 21 out of 60 at bats. 21 out of 60 at bats. Express the probability as a decimal number with 3 decimal places. Express the probability of getting a hit the next time as a decimal to 3 places, which is what they're asking you for. They're just basically asking you to find the batting average of that person. So experimentally what happened, 21 out of 60 times they got a hit. They just want you to convert this into a decimal with 3 digits after it. Best way to do that, Lenny Kavari? How do I change this fraction to a decimal? The 60 doesn't go into 100. What I would try first is do what? Anybody? What would you do first to make your life a little easier, Riley?
Simplify.
I'd reduce this fraction. What number goes into both of them? 3. So if you divide by 3, you get 7 over 20. 7/20 is what decimal? Well, maybe you know. You could figure it out over 100. It'd be what? Over 100. If you don't know, then just do the division for it. 20 divided into the top. 0.360. 20 goes into 100 times. Is that my answer? It's at 3 decimal places, so you'd have to go 350. That player is batting, as we say, 350. Is that a good batting average?
Yep.
I don't know for a softball player it is. Maybe not. Open your books, page 403, please. Just so you get a gist, it's really not that difficult. Look at letter B on page 403. It says, Quinn runs a sandwich shop. Since she added a turkey melt, I would have thought Quinn was a guy's name. Since she added a turkey melt to the menu, 36 out of 120 customers have ordered the new sandwich. What is the probability that the next customer will order a turkey melt? Well, that's pretty simple because it told you experimentally how many sandwiches did she have? 120? How many of those did she sell were turkey melts? What did it say? 36. Okay, that is your experimental probability. Of course, all you need to do is reduce that. What's that reduced to? Wait, did I do that right? 36 have ordered the new sandwich. What's the probability that the next customer will order a turkey melt? Reduce it, what do you get? 18 over 60? 9 over 30? 3 out of 10. 3/10 would be your probability. There's a 3/10 probability. So really, not a lot of math in there. They have to kind of give you the numbers for that whole experimental probability